when your PostgreSQL tables get huge, queries can slow down. One way to make them faster is partitioning. Range partitioning splits data by a column value. For example, we can keep all 2024 transactions in one partition and 2025 transactions in another. Queries that look only at 2025 will skip the older partitions, which makes them faster. Now, let's put this into practice. I'll switch to DbSchema's SQL editor so you can see exactly how to define a partitioned table in PostgreSQL. Here, I'm creating a parent table called transactions. Notice the partition by range clause. It tells PostgreSQL to split rows by transaction date. Now, I add child tables for 2024 and 2025. PostgreSQL will automatically place each row in the correct partition based on its transaction date. Let's check what partitions exist under the parent table with a quick query. Now, I'm inserting data into the transactions table. Because we created partitions, PostgreSQL will automatically place each row into the partition where its date belongs. 2024 rows go into transactions 2024, and 2025 rows go into transactions 2025. Because each row is stored in the right partition, we can't look at the performance benefit. When I query the parent table, PostgreSQL only scans the matching partition instead of the whole dataset. That's the power of range partitioning. Faster queries, smaller indexes, and easier maintenance as your tables grow. If you prefer working with a visual tool instead of writing all comments by hand, DbSchema gives you a clear overview of your database design. You can download it for free and try these partitioning examples yourself.